This video is going to introduce you to the notes and the focus and directrix form of a parabola. The quadratic equation for transformations, the one that is based on the general one that is on your transformation foldable, is f of x equals a x minus h squared plus k. The format is very similar when we're looking for the quadratic equation used for the focus and directrix. This one will be f of x equals 1 over 4p x minus h squared plus k. So that you can see a is really going to be equal to 1 over 4p, but we use that value to calculate the value of p. In a vertical parabola, the focus is h comma k plus p, and the directrix is y equals k minus p. Minus p. In a horizontal, the focus is at h plus p, comma k, and the directrix is x equals h minus p. You might want to add these things to your foldable, but at any case, you need to have these notes and put these in your notebook. One other thing that you should add is that in a vertical parabola, when p is greater than 0, it opens up, and less than 0, it opens down. That's 0. In a horizontal parabola, when p is greater than 0, it opens right. So, to find the value of p, you use the value 1 over 4p and solve for p. P is the distance from the vertex to the directrix, and it's also the distance from the vertex to the focus. So if I have a graph, and this is my parabola, the distance from here to here is equal to the distance from the vertex to the directrix. So this distance is equal to this distance. So those are congruent, those two distances. And that distance is p. So this distance here is p. Then you use the value of p to find the point of the focus. So given that information, we can now write the equation of a parabola. If we know that the vertex is at -3 and 7, and the directrix is at y equals 5, the distance from the vertex to the directrix is 2. So the distance from the vertex to the focus will also be 2. So 2 up from where the vertex is gives us -3, 9. So this is using the formula for a vertical one. This is h, which is negative 3. This is HK. H, and then K, which is 7, plus P, which was 2, gives us 9. Now, pause the video and you try the one on the right. So you do this one. So we've been told that the directrix is at x equals 12, which is here, that the vertex is at 0, 6, and we know because the directrix is vertical that this is going to be a horizontal parabola, and because the directrix is to the right of the vertex, then we know that the focus has to be to the left of the vertex. So this one is going to open to the left. So our p-value has to be negative, and the distance between the vertex and the directrix is 12. So the distance between the focus and the vertex must also be 12. So our p-value is negative 12. Our formula for finding the focus is h plus p, comma, k. So our h and k come from our vertex. H is equal to 0, P is negative 12, and K is 6. So our focus is going to be 0 plus negative 12, comma K, which is 6. Now, we want to take this one step farther and write the equation. For a horizontal axis of symmetry, the equation is going to be x is equal to 1 over 4p, y minus k squared plus h. Notice that k always goes with y, h always goes with x, so we don't have y minus h in the parentheses like we do for the vertical parabolas, which has x minus h inside the parentheses, which are squared. So now that we know that, we can take we know what the focus is, so we know what the value of p is. So we can write this equation as x is equal to 1 over 4 times negative 12, y minus 6, which is k squared, plus h, which is 0. So we don't have to write the plus 0, but h is 0. So this is our equation. We would multiply the 4 times the negative 12 and get negative 1 over 48. And that would be the equation of this parabola. So now it's your turn. Pause the video and work the problem to the right. Now we want to look at finding the equation of a parabola given the vertex and the focus. So we still need to find the value of p. We use the formula 1 over 4p use the value of p and the vertex to find the directrix, and then write the equation of the parabola. So we know that if our vertex is at negative 2, 3, this is our vertex, our focus is at negative 2, 5. So this is a parabola that is opening upwards. Our distance between 3 and 5 is 2, and that's our value of p. So we know that our directrix has to be 2 units below our vertex. So instead of being at 3, we go down 2, and this is our directrix, y equals 1. The parabola opens upwards, so, oh, I should have written it here. Y equals 1 is our directrix. Then we write our equation. Y is equal to 1 over 4 times p, which is 2. X minus the h from the vertex is negative 2. So minus a minus 2 is plus 2 squared, and then plus k is 3. Now it's your turn. You complete this one and write the equation. Now look at another one. In this case, our vertex is at 1, negative 5. There's a vertex. Our focus is at 0, negative 5. So this is our focus. So we know that this parabola is going to open to the left because the parabola always opens from the vertex towards the focus. The distance between the focus and the vertex is 1. So this distance right here is 1. Which is our value of p. So we know that our directrix then is 1 unit to the right. So our directrix is going to be at x equals 2. So now we have p, we have our h and our k, so we can write our equation. It's horizontal, so it's an x equals 1 over 4p, where p is 1, times y minus k, which is negative 5, so y minus a minus is plus, and then plus 3 plus h, which is 1. So that's the equation that we can write given the vertex and the focus. Now your turn. Add these notes to your notebook. Have these completed so that we can check your answers when you arrive at class tomorrow. Thanks for watching, and have a great day.